Everyone, welcome back to my channel. Don't fail asking Mikhail. Today we're going to work on the exponent rule or the property of exponents along with some examples. Alright, so let me share my screen. Oops. Exponents rule, we have altogether we have 7 rules. The first one is called the product rule. The product rule meaning if I have x to the a times x to the b, that will equal, if I have the same base, the base is x is the same, the base is x. The rules say I just add the two bases, so the answer is going to be x to the a plus b. All right, example, x to the 9th times x to the 3rd, that equal to x to the 9 plus 3, which is x to the 12th. All right. Now, the second rule is called the quotient rule. Now, listen to me. If multiplication, when I do multiplication, I add the exponent, the quotient means division. So when I divide, I subtract. Example, if I have x to the a divided by x to the b, that will equal x to the a minus b. As long as I have the same base, I subtract. So, if I have x to the 9 divided by x to the 3rd. Now, what is the base here? The base is x. The base is x. I subtract. That's going to be x to the 9 minus 3, which is x to the 6. The next rule is called the power rule. The power rule is when you have two exponent to an exponent, I multiply the exponent. X to the a raised to the b. You see I have two exponents here, a and b. So I multiply a and b together, so that will be x to the a times b. We're going to use this rule a lot. Example, x square, x square to the power 3, that equal to x 2 times 3 to the 6. The power product is when you have two things multiply, for x to the a times x to the b, everything to the power c. The answer here is you're going to take this a c and you distribute and the b and the a, so it's going to be x to the a times c times x to the b times c, or actually if you have two different ones, like another example will see easier and better. If I have x to the a times y to the b, you can everything to the c, that will equal to x to the a times c times y to the b times c. Example, x squared y cubed. Everything to the power 5. The rule says you can take this 5, you multiply to the 3, and also multiply to the 2. So the answer is going to be x to the 2 times 5, y to the 3 times 5, that will equal x to the 10th, y to the 15th. So you multiply this 5 to the 3 and to the 2. Power of quotient is the same thing. X to the a divided by y to the b, everything to the power of c. So the rules say you can take the c, you multiply to the a, you multiply with the b, and that will equal x to the ac over y to the bc. So example, x squared divided by y cubed, everything to the power 4. The rules say you're going to take this 4, you multiply to the 2, you multiply to the c, and the answer is going to be x. 4 times 2 is 8, divide 4 times 3, y to the 12. The next rule is called the zero rule. Anything to the power of 0 equals to 1. That is the zero rule is. 321 to the power of 0 equals to 1. The most important rule and the last rule is something called the negative exponent. All right? The negative exponent is anything to the power that is negative, you change position. X to the negative a, you change position, meaning it's not reciprocal. That's over 1. You put it down here, that will be 1 over x, and you put it as a positive exponent. Example. This is important because people think it's reciprocal, which is not reciprocal. 3x to the power negative 3 divided by 2. Now, 3 had a positive exponent that is 1. 2 had a positive exponent that is 1. But the exponent is negative for the x. So x is going to go down here with positive exponent. 3 is going to be the same. 2 is going to be the same because they both have positive exponent. And the x is going to be on the bottom with positive exponent. Another example. 2x to the negative 3 over y to the negative 5. Notice I have x to the negative 3 to the bottom. It's negative. I'm sorry. X is a negative exponent here. Someone was calling me. That's why I got distracted a little bit. All right. So x here had a negative exponent is going to go down here. The y had a negative exponent is going to go up here. So that's going to be 2. Y is negative, going to be on the top 5. X is negative, x is going to be on the bottom 3. So that's my final answer. All right, let's see some examples. I have 5 examples here. Let's work on them together. First one here, that's multiplication. So we're going to apply the power rule. When you multiply number times number, variable times variable. So I'm going to multiply the 2 and 3, x and x, y and y. So the answer is going to be 3 times 2, 6. X times x, x is the first power, x and x, we're going to add the exponent. And y to the first, we add the exponent, it's going to be y squared. How about this example? I have exponent and I have exponent. Remember the 3 and the x, each one had a power that is 1. So I'm going to distribute the exponent 4 times 2, 4 times 1, 4 times 1. So the answer is going to be exactly 3, 4 times 1 to the 4th power. X, 4 times 1 to the 4th power, and y to the 8th power. Well, the final answer would be 81 x to the 4th, y to the 8th, because 4 times 2 is 8. One more example. I'm going to distribute the power as well. That's going to be 2 times 1, that's 2 to the 2nd power, 2 times 1, m to the 2nd power, 2 times 0, n to the 0. That equal to 2 to the 2nd power is 4, m is 2nd power, m is squared, but n to the 0 that equals to 1, so we don't write it. And that will be my final answer. 2 more example. I have this one here. I'm going to follow a rule, always subtract exponent of the top minus exponent of the bottom. So we're going to do this one as if we have 3 different problems. Problem has to do with numbers. Problem has to do with the x. Problem has to do with the y. So that's going to be 4 divided by 2 is 2. X, always subtract exponent of the top minus exponent of the bottom. We're going to stick with this rule. So that's going to be x to the 2nd power minus exponent of the bottom is 3. And we're going to apply the same thing for the y. Y is the first power, y to the 1st power minus exponent of the bottom is 5. So the answer is going to be 2x to the negative 1, y, 1 minus 5 is negative 4. Now, every time you have a negative exponent, you're going to put it on the bottom. The bottom here is invisible 1. The answer is going to be the 2 had a positive exponent is going to stay on the top, x to the first power on the bottom, y to the fourth power on the bottom, because it's negative exponent. We'll put it on the bottom with positive exponent. Our last example, I have 3 and 2, so they're going to stay the same. 3 and 2. Now, I have x, y, and z. Always subtract exponent of the top minus exponent of the bottom. Exponent of the top is 2 minus exponent of the bottom is 5. Same thing with the y. Exponent of the top is 7 minus exponent of the bottom is 2. How about the z? Exponent of the top is 3 minus exponent of the bottom is what? Is 8. So top minus the bottom, top minus the bottom, top minus the bottom. So that's going to be equal to 3 over 2, x to the negative 3, y to the 5th, z to the negative 5. Everyone that has a negative exponent is going to go down there. So the final answer is going to be 3x over 2. The y is the positive exponent going to stay in the top, x to the third, z to the fifth on the bottom, because you cannot have a negative exponent. So I put the z to the bottom, x to the bottom, to negative exponent. Let me give you another example pretty quick. What if I have 5x to the 7, y cubed divided by 2x to the negative 3, y squared. So I'm going to follow the same thing. 5 over 2, I have x and y. Do the same thing. Exponent of the top is 7, then minus exponent of the bottom, copy the exponent, negative 3. All right? How about y will be 3 minus 2. All right, that is going to be 5 over 2. X, negative would change to positive to the 10. And y, 3 minus 1 minus 2 is 1. Final answer is 5x to the 10th y over 2. And this is my final answer. Well, I hope you guys find this video helpful to you. And now hopefully find the property of exponent or exponents rule a little easier. Don't forget to subscribe and hit the like and share button. And don't fail asking Mikhail. You guys have a great day, everybody. Take care.